tak za laptop zusammen.
Yeah. Or you can meet the live stream and just join in.
Yeah, I just want one more screen.
Oh, no. Don't move the laptop. Bring your laptop over.
Okay.
Or you can join the live stream on your laptop. You just mute it. And then you can let us know if anyone asks any questions. Yeah. All right, guys. So we'll get going with the next one. So does someone just want to close that door just in case the cleaners make a bit of noise? Thanks, guys. So me and Krisztian are going to talk about Roslyn and what we've been doing with it at Agoda. We've been working with it a bit the last sort of year or more. So I'll just start with a bit about ourselves. My name is Joel Dixon. I'm one of the dev managers at Agoda, for those that don't know me. I'm an N-Unit core team member and active, well, not as active as I used to be, contributor open source in the .NET community. I've been coming to Thailand for about 10 years for business, and originally from Australia, and I live in Bangkok these days, and I like beer and sport. Want to tell us a bit about yourself,
yeah,
Krisztian?
Sure, why not? So I'm Krisztian. I'm working for 1 year for Agoda. I'm an engineer here, and you see I like breaking stuff and sometimes fixing those. So I'm from Hungary. I like mostly C#. I do a bit of Scala, but it's blowing my mind sometimes, so I go back to C#.
So I'll just start with a bit about some of the problems that we had that led us to going down this road of using Roslyn analyzers. So one of the problems that we're running into, if we go back about kind of 2 years when I first got here, was we had poor reusability of code. We had people making amateur mistakes that were getting missed. You can only go so far with code reviews, which is a manual process that we were trying to use to pick up a lot of this stuff. Copy-paste coding, misuse of features, and all the above leads to code bases that are hard to work on. It makes people's jobs harder, and overall lower execution for the teams. So, has anyone else got these problems? Yeah? Yes. Well, someone on your team just put their hand up.
Yeah, sometimes it happens.
That's on the legacy code, right?
Yeah,
not the new stuff you guys are writing. Yeah. So yeah, these are some of the things that we were dealing with, and we're looking at better ways to deal with them. So Roslyn analyzers is one of those ways, and I'll hand over to Krisztian to talk a little bit about Roslyn, and then I'll take over a bit later.
Thank you. So let's start with some history, I guess. So before Roslyn, what was actually the situation in Microsoft? So they actually wrote a native compiler for C# and it was fine for different use cases. So after a couple of years, they started to realize it's actually not enough. So what the old compiler does, you get the files, you get the output, like a DLS there, everything is fine. But what if I want to hook up something during the middle? I want some information about my code during the actual compilation. I want some meta information actually that I can reuse later, or generate reports, or anything else that's diagnostic heavy. So for do this, actually they started a new project called Roslyn, and basically re-implement the compiler and add some cool other features also. So anybody else heard from Roslyn before? The name? Cool. Do you know when is it released actually? The first version? Just take a guess. How many years ago?
I think about, I thought 4.
Yeah, it's actually came up with Visual Studio 2010 SP1, so it's actually 6 years from now. Nobody knows about it. Why? Because they starting like literally shipping in small pieces. So they actually ship the compiler first and after the other services. So what exactly Roslyn? So it's actually a compile platform and a metadata provider for your code and the language service. So there's basically not just compiling your code. When it's compiling your code, it's doing some extra stuff, capture some metadata. and actually feed your IDE also. So if you see the platform itself, we already knows about this stuff from the previous conversation, I guess. Syntax API, parser, meta information. So it's doing the same stuff as the compiler, but it's actually capturing all of these contexts. So what does it mean? So like from the parser perspective, you get those tokens. From the meta import and symbols, you know what it does, what it can do from like your API layer, what information is required. The binder, you actually grab the whole context. Why is it good? Because you can actually have this metadata in your IDE. So if you see these colors, it's actually matching with every stage of the compiler step. So I guess it's the rename features, find our references, exact method. You see it in your Visual Studio or Rider actually. It's actually using those meta information that's provided from the compiler. So the Microsoft team actually rewritten the IDE stuff also with these new language providers, which is feed from the compiler level. So what you get from everything that the compiler knows about your code, actually your IDE is already know. So what you can do for it is like you can format your code as you want by configuration, because you know how the code looks like in compiler level. What you can use diagnostic. When the compilers run, you can say it's like, oh, I see it's a bad code. You can write your own custom providers that say, if you see this, please provide me an information that it smells. It's like looks really, really, really bad. All of these stages are actually, yeah, exactly. So how Roslyn actually looks like. So these are the main APIs that you have, like you can use basically. So the compiler APIs, you can get the syntax tree. Basically, all of your tokenized code is represented as the tree, and you can read and actually set those trees during the compilation. So the workspace API actually the biggest one. So this is basically the umbrella API around all of these. So if you code against Roslyn, you mostly use workspace API because you need like different sections from different stages. Like you want to load your code, you need your workspace. You need like the files that's provided from your workspace. You need to use which ID and which language features are you using. The features API is like a most top APIs basically. So if you came from your IDE perspective, it's actually this is the top one that you always see in your IDE. That's right-click, refactoring my code. So this is the one of the biggest topics that we want to talk about is the analyzers. So why is it good to create your own analyzers, or what is the analyzer itself? So you end up in the situations where you want to force some rules, or you want to tell basically the users, if you are in this code base, you are in this project, I want to give you some feedback like immediately. Why is it bad if you're not using like Roslyn analyzers? Because like send a pull request. Somebody apply like, yeah, format this code like this. You get the feedback like, don't use war in your code in C#. Don't use like this. Why you not enforce while you are writing your code? Somebody tells you like, hey, in this code base is actually, you cannot use this. Please use this. So why not get like immediate feedback without doing all of these code reviews? You're sitting there next to each other. You like spend half an hour arguing about, yeah, I want to use this. No, you cannot use this. In a global level, you can write your own rules, your analyzers. And actually, Roslyn has this ability to extend your, like, basically IDE with these analyzers. And it's actually not just with Visual Studio, so it works with Rider. I don't know anything else that's
Visual Studio Code.
Code, yes, it's working in code also, yes. Vim? It's working on Vim? Ah,
Yeah.
it's new information. So it's more broad than I thought. So what it does, the analysis is you can produce custom diagnostic messages. It's based on your IDE, how is it reported, it's a pop-up. In Visual Studio, you get this beautiful popover of your code, basically. If you see the bottom, it's actually the next stuff that I want to talk about is the code fixers. So what is the problem with analyzers? So you analyze the code, you get some feedback from your IDE, but I don't know what I can do about it. It's like, yeah, this text, I cannot even understand why this analyzer is crying on my code. I think it's good. So in this case, the code fixers can be solved this problem because you don't need to do actually anything, just clicking, okay, fix for me. Because I don't really understand why I need to rewrite my code, why I might need to use like braces in my F. So it can help you to basically rewrite your code as the project structure or project owner wants. So you can use Roslyn to basically restructure your code, reformat your code, actually completely rewriting exactly. And you can keep the context. So why is it good to use Roslyn for it? Because there is so much information that you need when you want to like replace the code. Like if you can start from the regex perspective, you can write a regex to rewrite codes. But regex is not understanding code itself. You don't have the types, you don't have the type system, you don't have like basically the tokens itself. What does it mean in this code base? You cannot specify in regex how the code itself looks like in runtime. But in Roslyn, because they knows about the types, it's actually compiled your code, so it's know every metadata basically. So this is the Agoda project that we are working on with Joel. We got 3 rules from ourselves written. We really just getting started. You can check this out. I created a branch that you can pull, and I will show some demos now, probably. Let's see.
So not to unmirror.
Yeah.
Mirror. No. Oh, yeah, you're going to change.
Oh, or I can just put it there.
No, because it needs to be on the external to go to the feed. So you'll have
okay,
to
cool.
swap the desktop back and forth. No.
No, not this one. Because I will see the main one in this case.
You will see it, yes. But the people on Facebook will not.
Oh, cool.
So just change your desktop back to mirror. You can just like do function and then that key.
Okay.
Yeah.
Cool. So what I'm gonna show you is actually a really easy example first. So I've wrote an analyzer and a fixer for basically put braces for after if sentence every time. So basically, if you want to write an analyzer, you see you need to extend the diagnostic analyzer. It came from basically the code analyzer library from it's a part of the Microsoft code analysis. So if you see, you have to add some diagnostic ID. It's basically the identifier of your Roslyn code. You need to provide some meta information that the IDs will use to show you some information. So the main thing is you need to register your action. So it means you need to define where it actually came up. So when Roslyn going through your code, you can define as like, this is basically the trigger or event that I want to listen, and I want to see, and I want to run my code. If you see this analyze syntax, it will run in every if statement. So what I'm doing here is basically capturing the node, see if it's a if statement with a block expression, so it has braces or not. And if it's not, I just get the location where it's in the IDE and diagnostic. I actually tell the diagnostic API to notify the user to see this warning. Basically, you can set severity as you want. If you want errors, actually you can redefine this in your rule settings per, I think, per solution level. So you can say this analyzer is basically should cause compiler error if it hits. The other thing that I implemented is the code fixer for the same thing. So I bind it to the same diagnostic ID. This is how your ID will know if you hit this analyzer rule, if it's failed, show the code fixers below. Like in Visual Studio, you see like please fix this code. So this is how it's like binded together. So this is basically the registration, same as before, same as the analyzer. You can grab the syntax. If it's block without block expression, you just apply the code fixer. So this is the register code fixer. This is code with your code context basically. You configure basically the diagnostic place is basically the IDE or the source is telling you this is where the rule is hit, basically the source code. So you want to notify the user the same point at he hit basically the diagnostic. So what I'm doing here, it's actually searching for basically the declaration of that if statement, and I apply my rewriting rule here. So the rewriting is actually, I grab the node, I say I want to insert the braces in like before and after, and I just put the existing node in the middle. So how you can test your providers? It's really easy. You can set up, it's actually the organizer. So you can set up this V6, which basically, if you press F5, magically will compile, I hope. Yeah, my machine is pretty fast. So to test the analyzers and your code fixers, basically you start debugging a new Visual Studio instance. It's automatically bootstrap and configured, basically in debug mode, we can say. Oh. I think while it's bootstrapping, if you have any questions, you can ask about it. Cool. So if you see in the top, it's actually the debug mode of the Visual Studio. So you can inspect element and see what's happening inside. It's actually pretty cool. Let me create a new project. So console application 6, yeah, it's a pretty good name. Okay, so finally we arrived here. So it's your project basically, and let's assume I want to write something like, it's really cool typing in one hand. So I want to break basically the rule. So just using some basic abstraction, and you see it's actually the Visual Studio is already compiling in the background. It has this MS build process, and I'm breaking my own rule. So if I hover over for this bulb, and let's see, oh, add required braces. It's pretty cool. So it's just rewriting my code as the other ones. So, what do you think? Is it cool? Huh? That what I wanted to show, it's actually, so this is a like a really easy example. You can do it your own. The Roslyn API syntax is pretty heavy, so I would say it's not like you start it in 1 minute, you can build any analyzer that you want in my mind. But the documentation for Roslyn is actually pretty good. They are really open source, so if you see the issue count, actually you will see it's pretty active also. But there is not real issues. If you want to start with Roslyn, I would say read the documentation first and get over this lexical and syntax tree, because I think this is the hardest. But after that, I think if you had any question, you just ping them in Twitter. That's the most active community probably in Twitter. They always answer in like probably in half day or something. What I wanted to show you is like how actively you can use. So it's a more robust analyzer that I see. So this is part of the not released Visual Studio analyzers. So you see here, this analyzer is actually capturing async stuff. And if you're using some APIs which can block your thread and goes to thread starvation, it's actually prevent you to use this. So you get notification on ID while you write your async code if you are using wait or result directly, and it can block your thread and it goes to synchronous mode. The other stuff that I found yesterday, so this guy is pretty active in Roslyn. He's working for Microsoft. So what it does, it's actually for regex expression is write an analyzer which can compile our regex expression and see what is bad, what is good. So it's like you see, it's actually a compile error for regex, which is pretty cool. I never see this feature before in Agoda. The other cool stuff that will came with, I think, which version? This version of Visual Studio is, where is the picture? So button. Where is the format? Here. So you can actually write this also with Roslyn analyzers to format and colorize our regex expression, which is, I think it's pretty cool, and I'm really waiting for this feature. So let's back to the slides. And let me hand over to starting over.
Yeah.
We need to do the magic again.
Yep.
So while Joel is switching to another stuff, thank you for listening me. And if you have any question, I will be nearby for half an hour, 1 hour, I don't know. Cool.
Yep. Okay.
Let's just stop.
Thank you. All right, so I'm going to talk about how we actually implemented Roslyn into our build pipeline. Oh, hang on, that's not right.
It's not right.
Yeah. We shouldn't be showing the notes up there.
I see.
Yes.
Just change your display settings.
Yeah.
Yeah.
So if you have 5 and just revert the, no, just go back. F5 and put this one.
Yeah.
So, and start over again.
Hang on, as long as that one's right. No,
It's not right.
it's not right. How is that even happening? So, no. It's the Krisztian stuff.
Yeah.
Extended display. Okay. Cool.
Magic.
So, I'm going to talk a little bit about, like I said, what we did in our build pipeline. We implemented the GitHub integration. We wanted to implement GitHub integration with our PRs. We're using Sonarqube for reporting, and it also helps us out with the GitHub integration as well. And there's also some other tooling that we had to use to get it working. We're trying to make the developer experience better. So you don't want to add blockers, because it's very easy and we've had the same problem with code reviews as well. Like, it really sucks if you're ready to go live with a feature, you send your PR for a code review, and you get like, 100 comments of this is wrong, you need to fix that, you need to fix that, you need to fix that. So we didn't want to take that bad experience already and just make an automated tool complain about people instead of people complaining about people. So we didn't want this guy. We didn't want our CI process going, no, you cannot merge, you've got to fix all this. So we wanted to look at what we could do to improve the experience. So when we block someone, we need to empower the developer to unblock himself. This is one of the key things to making this work. So tools that block people are annoying. If I have a tool that says your code sucks, try again, it's not really helpful to people. If I have a tool that educates people, it's better. If I say your code sucks, improve your code this way, it's a lot more productive and empowering for the developer. But the best kind of tool is the ones that fix it for you. So a tool that says your code sucks, click this button to make it better. So this is this is Sonarqube. It was one of these tools that we used to do this. And this is actually looking at one of our projects. So it gives us this nice analysis of how much technical debt that we've got, code coverage, and it even does rolling changes. So report on over time. Are you increasing your coverage? Are you increasing your lines of code too much? Are you dropping lines of code, which is awesome. The Sonarqube is awesome because it supports 20 languages. It's also a real big pain in the ass because it supports 20 languages. What you'll find if you use this tool is that every time you add a new language to it, you need to learn a new way of using Sonarqube, because each of the language implementations for Sonarqube have different open source communities that live around them. So we originally set this up for .NET, but then when we wanted to set it up for TypeScript to analyze our client-side code, it was like learning the whole thing all over again. And I haven't even looked at setting this up for Scala. I think some of the guys on the back end have been doing that. But yeah, and mobile will be another pain, I'm sure. So the good thing about it though is it gives you standardized reporting. And this is one of the key things about visibility, about going down this road and cleaning up your code base. So I'm sure that we've all got code bases that are not so good, but the question is, how not good is your code base? How is your code coverage going? How are your lines of code going? If you can actually measure these things around your code base, it will give you things to work towards. And it'll know how much of an impact the changes that you're making when you start to implement these tools are going to have. So this is how we got it working. So Sonarqube slots into our build pipeline along with the Roslyn stuff. So basically, with Sonarqube, it has a Sonar runner, which is a plugin for TeamCity. If you're using TeamCity, you can download it. If you're using Jenkins, there's a plugin as well. But basically, our build pipeline looks a little bit like this. We have a Node.js transfile build and a C# build that run. And now out of the C# build, we bootstrap our unit testing with .cover and get a report. We bootstrap our jest test from the client side, produce a report as well. And our TS-lint does our static code analysis for TypeScript and outputs a report. This is some of the learning we had to go through because with C#, it's okay to let your Sonarqube runner itself do your analysis and your rules, but you don't want to do that with TS-lint because the way that they've been built is different because different people build So your Sonarqube runner on your build agent basically takes the output from all of these. It'll analyze the .NET code. It analyzes the TypeScript using the output from TSNs, and then basically batches all this data from your code coverage and analysis into the Sonarqube database that gives you your nice UI for reporting on how your code's going. And I've got a blog post if anyone's interested in how we did this, on how we set it up, a multi-language project with Sonarqube. It'll give you advice for TypeScript and C#. If you're using other languages, I can't give you any advice. I'll just say good luck to you. This is the GitHub integration that Sonarqube uses. It's really cool. It basically uses the Roslyn analyzers under the bonnet, and also any other static code analysis that you tools that you use along with it. So it's now doing our TypeScript analysis. And what this integration will do is when the analysis runs on your build, on your PR, the output from those rules on the code that you changed, it will inline comment on your pull request about problems with your code. So this, and it can block developers as well. But the good thing about a tool like this is it doesn't just block you, it tells you what's wrong with your code. So you can see here, my pull request, I've commented some out some code. We've got a rule that says don't check in commented out code. Obviously, the reasons for that are clear. And then it also has a little hyperlink here that deep links inside of Sonar to explain the rule, give you some details about why the rule's bad, and yeah, once you fix the rule, it'll go away, like someone's reviewing your code. So there's a good blog post from the JetBrains guys about how to, from the Jet Abroad guys about how to set this up. Is there anyone from Jet Abroad here today? No? Okay. So I recommend checking out that. That just shows you how to set it up for C#. Again, other languages, good luck. But the thing that's nice about this tool is that it will analyze all the files that you've changed. So if you update one line in a file, it'll reanalyze that entire file and complain on your pull request about that. Now, when I first introduced this, developers started coming to me and going, Joel, we need to turn this off because it's telling me to fix other people's code that I didn't even write. And my rebuttal to that was, if you don't fix it now, who is going to fix this code? So if we approach it one file at a time, we might actually get on top of this and get this fixed up. So I think this is actually a good thing. I try and encourage with my developers in my team a culture of leaving things in a better place than what you found them. And I think that's the only way that you'll ever get on top of mountains of technical debt is by, we're working on this particular area, it needs a bit of a refactor, let's do it now. So getting your rules into Sonarqube. So one of the things that we've done, like we said, we've written our own custom rules. We've got this analyzers project on GitHub. You can use it too, and you can contribute to it. But the problem with the Roslyn analyzers projects is Sonarqube was originally built by Java developers. It's written in Java. It's open source. It's got an enterprise version that's not free, but I don't think it's worth buying. The free one's fine. But the problem is, because it's built by Java developers, the Sonarqube plugins are a jar file input, and from the Roslyn Analyzers project, you get a NuGet package file output. So we've got a bit of a square plug round hole issue here. So so there's a Sonarqube Roslyn SDK that the Sonarqube guys developed and then didn't touch for a year or two, so it was way out of date. So we've forked it, cleaned it up, updated it to Roslyn 1.3. We'll probably update it to 2.4, the latest one in the next couple of months. And what it does is basically just take your NuGet package inputs and convert it to a jar file that Sonarqube can then suck up and start analyzing all your new rules. The advantage of this is you can take advantage of all the Sonarqube reporting along with the analysis of your custom rules. So if you want to do something like you find a new bad thing that your developers have been doing for the last 2 years, you can add in a rule for that, publish it into Sonar, and then Sonar's code smells will go through the roof as it finds all these new problems that you want to get fixed. And again, you get this measurement data back out of your code base that you can use to monitor, see what effects you're having on the code and so forth as you're embarking. So this is the metadata fields for Roslyn that I was talking about. Basically, it pulls these from the data that you provide inside of your analyzers in the Roslyn project, and the command line tool will basically extract those out of the code and put them into the database in Sonarqube. So we can do things like write little, this is an example of bad code, this is an example of good code, and this is why it's bad code and shouldn't be used. So again, we empower developers to fix it themselves. It becomes more of an educational tool than a blocking tool. And this is also the same metadata that you'll get in the UI in Visual Studio as well. So how this works, so the Analyzers project, we basically set up a bit of a continuous delivery system. So the github.com Analyzers project has a build that runs an app via, and from a master merge will deploy to NuGet.org. So we can continuously publish this package of rules up to NuGet.org. On premise though, we have a Sonarqube server. What we basically have is a TeamCity server on premise that listens for new NuGet.com packages. It will then run our little command line tool to build a jar, and then we use our deployment tool, Octopus, to push up to Sonarqube, and then it just basically copies the jar file in and restarts the server when new rules are available. So this is a really easy process to basically automate the update of our Sonarqube server from the custom rules that the developers are writing. So there's no manually copying jar files and things like that. So I'm also putting a blog post about this probably tomorrow. So if anyone else wants to do this, set up Sonar on site and start consuming the rules packages, you can just go through and have a look at it. So how to get started? So if you want to get into this, I would recommend installing Sonarqube. It's free. It comes with good default rules as well. You don't even have to use our rules. You can get started with it, get it installed, have a look at the blog post that the Jet Abroad guys did. It's really cool, and you'll start getting this reporting out of your code base. The GitHub integration is easy to set up as well. The blog post examples have got TeamCity, but it's not that different for Jenkins if you're using that. I don't know about team services if you're using that. It's probably even easier. Once you've got that set up, install the Agoda Analyzers rules too. It's just as easy as adding a NuGet package from NuGet.org to your solution, and then you can start using our rules as well. And if you've got rules that you want to contribute to the community, we welcome pull requests if you want to share. One of the things that we are doing with our rules, though, is we're being very opinionated because we think we know how to write .NET code really good, and so we're writing a lot of rules that enforce things that you probably wouldn't get in community rules because they're pretty strict. So if you do go through this, though, one of the things that can be a bit daunting is the first time you run Sonarqube on your project, you'll probably get a lot of code smells reported. When we first started playing around with Sonarqube about 2 years ago, everyone told me it was a stupid idea because what you do is you run this thing on your big code base, it picks up 15,000 code smells, and no one's got any time to fix 15,000 code smells, do they? So, where do you even start when you get this many code smells? Like, you can't just dedicate a team for 6 months to go and fix code smells. There's not much business value in that. What I'd recommend doing if you're going to take this approach is use the code review block. It will only look at files that have changed, and start there. Use the reporting in Sonarqube to track your progress, see how you're going. I'm sure we all work on some legacy code bases, and you can't just stop work for 6 months and fix all the issues, but you can fix them as you go. You can leave things in a better place than you found them. So, slow down, overestimate your stories to account for refactoring, because it's the only way you'll ever get it done. Fixing and refactoring things as you go, and eventually you'll get there. And when you get there, you'll have happy developers, because it'll make developers' lives easier and their jobs easier when you have a nice code base that's easy to work on. They won't be chasing down production issues as much. They'll have more time to think about innovation and less time to think about maintenance. And it also results in happy product owners. A lot of people that I meet, a lot of developers I meet and talk to, sometimes say that they have problems talking about, getting technical work or refactoring work done with their product owner. But I don't. I think it's a really easy sell. Like if you go to your product owner and go, hey, if we concentrate on technical debt, it'll eventually improve the execution of the team. You'll be able to get more features done. It's a pretty easy sell in my mind. So that's basically where we got to and what we've done. So is there any questions, guys?
A question about basically it's with the it checks for whether it's this code with comments. I mean, it basically imply enumeration of anything that represents code in that language. How do you think the idea how it's actually figured out?
So there is two things that it depends on where. So when you open in Visual Studio or when you compile. So when you open in Visual Studio, the diagnosters basically only run on your code base that you see. If you use the build, so it's like you trigger MS build if you're going through all of your code. So, but because they're collecting and it's actually async, so every diagnostic rule is asyncly like populating all of these diagnostic messages, you don't get any like huge performance load. There is some time that's like extra cost for your IDE to show those bubbles and messages, but it's not that much. So it's actually not like scanning all of the files manually one by one. It's like asynchronously building, like MS build multiple processes. So you can just have this feature.
It's the same for when it's within the Sonarqube message.
Correct.
Basically,
Correct.
The same one.
Yep.
What if you have two rules on one like if statement? You have to say, okay, if it's one statement, then I want to fix this. So then you need to set the priority order on that in your diagnostic.
So actually you can do a toggle. So just switching back and forth, because two rules can confuse each other like easily, because you don't have like so actually you don't have communication between two rules. So it's like they totally separated. They are running like multiple threads, they are analyzing stuff. So if you had a rule which is forcing you to put brackets, and if you had a rule which is forcing to not put the brackets, you can just confuse it. You get this toggle effect when you have back and forth with the analyzer.
So like no rule wins?
Yes. It can be multiple actually. So it can multiple rule wins and no one wins basically. So you can have something that's trigger multiple builds. But currently you cannot apply multiple changes in one turn. So if like you hit like 3 rules in the same line, you need to apply one by one, because there is no way you can trigger all of them to apply, because you need, on that case, you need to run 4 in the same time. So it's not possible.
So you're saying that I get a message with 4 rules, but
Yes.
the potential fix I need to.
Yes, correct.
I see. So the syntax can get quite heavy.
Yes.
How long does it take? If someone's starting this kind of fresh, how long does it take to get productive in this for more complex rules?
I don't know in general. I can tell my intel. So when I started, I was reading about blog posts mostly. It took me like a week to know if I need to search for something, where can I find? So it's like in Roslyn repo. I mostly use their examples. So when I started, I found an example which is kind of match or doing kind of same thing that I want, and just reapply my rules. So in this case, after a week, I was like easily write a rule in a few hours. But if you don't find your example, like I was searching for something to apply a rule if it's used in my code base. So kind of thing, it's like you are not only using a rule itself and your code, you're trying to scan all of your code base. So for this case, I opened an issue actually in Roslyn, and they said it's like, you never do this. It's like, if you want to hang your Visual Studio for 15 minutes for a good big code base, never do it. So there is a limitation also. So if you're trying to reparse again 10,000 files, it's not gonna work. So for my Intel, first read the documentation in the repo wiki, and after that see their examples. It's really easy to catch up with those examples, because if you start to reading all of the API keys from Roslyn, you're never gonna end it. Cool.
All right, cool. Well, thanks, guys.
Thank you, guys.
There's a feed.